Hi there, folks. Hope you're doing all right with all these magic moments that we're playing with. I've got a request from, this one's from Hannah. This is 4B, exercise 4B. It's page 76, and it's question 5. A bit different because we've got a cruise ship tethered to a dock being moved by 3 tugs, and we've got a rectangular lamina that we are looking at this as PQRS. So like a piece of paper that we can shift around, and it's got everything in the description there, and we're trying to work out the direction of rotation of the cruise ship and what that moment is that is rotating it. So here's their diagram, which basically tells you everything you need to know. I've drawn my own over here for speed. I've already got that down, so that we can then have a look at what's going on and I can draw all over it. Okay, so here's our dock at a P. That's our fixed point, P. So the thing isn't going to move side to side. It's just going to twist because it's fastened there. So we're not worried about what force is going on at P. We just want to look at the twists around P. The reason this is interesting is, although we definitely want to take moments around P, what we've got is forces all sort of attached at different places on our lamina. So how do we tell what the perpendicular distance is? And actually, there is a simple and a slightly more interesting method for doing this. Let's take this 5,000 Newton force. This is going to turn the whole thing. If you imagine the pen as the lamina, it's going to twist it around this point P that way, isn't it? So this is a anti-clockwise moment. So I might make a note of what's going on anti-clockwise here, and separately have a look at what's going on in the opposite direction. So this one is definitely turning it that way. What about this 4,000 newtons? Which way is that turning it? If we look at the direct line between this point, I think we call it B actually, between this point B and P, the force is actually slightly to the right of that line. So it's going to be pulling it in a clockwise direction. It's actually pulling it down off that line. And also this force, again, it's pulling downward, so it's making a clockwise twist. So this one's also clockwise. So use whatever notation you want just to see how this is balancing out. So we reckon these two are fighting this one, and we're not sure yet which one's going to win. But we're going to use moments to calculate that. So let's look at this force up here. Now, the 5,000 newtons, we need to find its perpendicular distance from P. And actually, there's a simple trick with this. If we draw a straight line to R, then it's not at a right angle. But if we track the force back, it could actually be thought of as acting all the way from S. So it's like it's a force at S pulling up. So actually the perpendicular distance, because these are all right angles inside this rectangle, that distance from S to P is 240. So in the anti-clockwise, I'm going to put this 5,000 Newton force, 5,000 newtons times the distance, which I've decided is 240 meters, because that's this distance here, and we're looking at a rectangle. Okay, so that's force number 1. Now, force number 2, we've decided this is acting in the other direction, the clockwise direction, so 4,000 is going in here. But it's perpendicular distance. Let's have a look. Now, there's 2 ways to do this. I'll show you the other way when we get onto this last one. But if we think about this, tracking it back we can think about where this line goes. We can track our force back all the way to there. And if we think about what it's doing at this point, this force is pulling 4,000 newtons through there. And it's also sort of levering this side around. So the actual perpendicular distance of the force at that angle is only this little 30 meters in here, because it's halfway up to the 60. Yep. So again, drawing that force arrow a bit longer, you can see where it passes the point P. So my distance is just 30 meters for that one. Now there is another way to do that one, and I'll show you it on this last force because it seems to be a more logical way to do it. I could track this back and try and find where there's a right angular triangle in here. I could try and do that, but that involves a bit of extra kind of triangle work. So I'm going to split this force into its components. So really, I've chosen the lamina, the rectangle, to be my frame of reference, and I want all my forces to be lined up along its sides. So I'm going to split it into these two components. Again, like all forces, this is the hypotenuse of the triangle. We've got these two components. This one here, moving through the angle, it's the adjacent side of my right angled triangle. Here's the hypotenuse. So it's the 6, probably there before me, times cos of 50. And along the other side, 6,000 sine of 50. So the part of that that's providing a moment, a turning force, is not this one, which is pulling directly away from P, so it's not having any twisting effect. It's this one over here that is trying to turn it in a clockwise direction. So we're going to add that force on. So the actual force that is turning it is 6,000 sine 50. And the distance, well, A is the midpoint of PS in the question, so it's times 120 meters. Okay. So we still have a perpendicular distance. Okay, so these are the two things we need to compare. I did do this earlier but got disturbed. This ends up as 1,200,000 Newton meters. And this bottom pair, we get 120,000 plus 551, 552. And that gives us 671, 552 Newton meters. I did work those out beforehand, I'm not that quick. Okay, so what we've got is a net effect of, it's actually this top one, the anti-clockwise of 1,200,000 Newton meters is bigger. So we have a turning effect that is anti-clockwise. That way. And the size of this is the difference between them. So it's the 200,000 Newton meters minus the 671,552. So that is 8. But I've had to borrow. Got to borrow all the way from here. Remember doing this at school? 9. And borrow becomes 9. So there we go. 4, 8, 2, and that's a 5 there. So that is my turning moment. my net moment for this boat. So it is going to turn. So yeah, unusual question. I hope that helped. Back soon.